Here we can see a complete mold tool assembly. By switching off the injector side, we can see two sliders, an insert and the lower half of the tool. So we can have a look at one of these inserts. Just change the work plane here. We're looking top view. We're going to create 3 electrodes. The first electrode is going to be for the 2 tags shown here. So into my top view, just going to select that solid. We'll now have active this toolbar. Now, just going to do a lasso selection all the way around these top 2 regions here. Come into my solid core capture, and then apply the necessary oversizes to get the selection covering the whole area. Apply an oversize of 1 mm, and then change the direction here just to increase that to an overall height of 8 mm. Once that solid core is captured, I then need to apply some clearances. So on the 2 inside faces, I'm going to select these first 2 here, and the opposite side, holding down my shift key, so I have all 4 selected. I'll come into my general edit tools and do an offset here of -1 mm. I'll get the blue outline, give me an indication of where I'm to go. That is correct. I will accept that. We can see we have this radius here, area here naturally extended. What I would like to do now is just select these faces and remove them entirely. So I'm going to select the first 2 internal faces, do replace face to the outside, then using the right mouse button apply, have that removed. Again on the opposite side, I can select the first 2 internal faces, select the external face, then using the right mouse button apply, also have those removed. All I need to do now is just apply some clearance to the top here. So I'm going to select that single face, then move that in Z 1 mm. I have now applied all the clearances necessary for this solid core capture, ready to turn it into an electrode. So now make the insert active, ensure that's active, select the solid core capture, come into my electrode wizard. Does it include a base? No. This way the wizard will put it on for me. Automatically selects the blank size that is appropriate to that solid core capture. I can rotate it round and see it here. Even at this early stage, I can do a simulation of the electrode. Move to my next screen. We have 3 holder catalogues at standard: eRover, Hirschman and System 3R. This instance I'm going to use System 3R. Holder has been applied for me. If I zoom out now, we can see that holder been applied. Go to my next screen. Now I can enter in the first level that would like this electrode started from and a counter. Notice when that's done, this naming format down here changes. The electrode naming group electrode here and here. I can go to my next screen. I can apply here spark gaps automatically using the undersized data sets of AGI, OPS or Zimmer Crime. This instance I'm going to use OPS. Go through to my final screen. I'll do no export and I'll finish creating my first electrode. So here we have the setup sheet with the overall sizes. The general assembly sheet has now been updated with that size on and position. I can come back now and do my second electrode. So I'm going to turn off the electrode group, come back into the top view here. My second electrode is going to cover the whole main area. Now when we're doing a solid core capture, that works by using the extent of the faces selected. So here I'm going to choose these 3 extents in the X, Y and Z. Then when I come to do my solid core capture, the block will cover the area of those 3 faces. I can apply an oversize here of 1 mm, then just apply some height on here manually, make it 25 mm. Now I've captured all the way around here. Now I need to remove these excess faces. So I'm going to come across, just draw around here with that lasso selection. Just select those faces here, and I can use the shift key with the left mouse button to select any others that I wish to add. Now use the replace face, select the fireplace and apply. Again on the far side here, just remove that menu just for clarity, just for this demonstration. Again, just lasso selection around. Selected all those faces, use the replace face, and then apply. I could use that face up, select the two faces, and choose the replacement face. Then the right mouse button, I can do apply, and again on the opposite side. Select the first face, select the second, select the replacement face, and right mouse button apply. I'm now going to remove these tags. We can see at the top up here, they're not required. Have these in a separate electrode. Select the outside face here and replace that to the inside. Again, use that right mouse button to apply. Select the outside face, select the inside face, right mouse button, apply. Now it's coming to my bottom view. I'll remove these two tags from here. So again, just draw around here. This time I'm going to use the remove and heal. I could have used a discrete lasso here just to come round and do a straight selection all the way around and use the remove and heal. Now in this face in here, I would like to do that on a separate operation. So I'm just going to select the single face, remove and heal. All the adjacent faces then are extended and re-intersected. These shutout faces here, I want to apply some clearance. I'm going to select those four individual faces. Then under the general edits tools, I want to apply an offset here of -2.5 millimeters. With these faces still selected, I'll use the remove and heal just to finally take them away. Now I'm going to have a look at the top up here. There is a pocket here with these faces captured. I'm just going to select here these 5 faces. I want to apply a move in here. I'm just going to put a little bit of clearance on first of all, just 0.5 millimeter, just so we can see then the extent of that coming down. Well, if I'd like to extend that further, I could apply then just a further move. We can see it moved all the way down. But notice we have some fragmentation here. If I go to my next solution, we can then remove all that fragmentation to have nice, smooth, continual faces. What I can see on here, before I do any further operation, I can see where these two faces are. There's quite a nasty kink inside this face. And if I have a look on the far side, it's also around here. So we're going to use some new functionality here, and that's the ability to merge faces. So I'm going to select these two adjacent faces, come here into merge selected faces. When these are joined together, we can see then that's removed. Do the same on the opposite side. Merge these together. I'm now going to apply a clearance in this horizontal face. So I'm just going to select it, come into my general edit tools, come into move. I'm just going to apply here a clearance of 0.75 millimeters. Now use my next solution here. We'll see then in this area then we can naturally extend the internal surfaces just to flow. Now having done that, what I'm going to do now is just remove this area from the side here, just make it nice and smooth, much easier to machine. So select the first face, just replace it to the face on the far side. We have that blue outline giving the indication. It's absolutely fine, we have now done that. If I then decide that I wish to apply further clearance onto this face, this solid core capture is perfectly fine as it is, but if I require a further clearance, I'm going to select the face then, and again just extend that further 1.25 millimeters, making 2 millimeters overall. Come to my next solution, and I've automatically done that. This is highlighting the ease to the user of using the next solution on the general edits toolbar here to give next solutions when there are multiple solutions to offsetting faces. I can turn this solid core capture now into an electrode, ensuring that I've got the insert active. Select now that solid core capture, come into the wizard. This instance I'm going to say yes, it does include a base, so therefore the wizard will not put one on for me. I'm going to use a user defined here, electrode blank size, showing that we can create here the length, width and the height, material, full control over the centre of the blank top and the datum. I can rotate it round here in the wizard. I'm just going to use the same holder that I used in the first electrode. Now you can see the level has increased here by 1, and so is the counter by 1. Here we have the electrode group and the name. It's all done automatically. We're going to use this undersized information the same and just finish off this electrode. Again, this is a setting sheet. We look at the general assembly drawing now. That's been updated for the second electrode. To see the position of the first, I can just turn it on here at the level. Come back now to my session and I'm going to create my third and final electrode. So here I'm going to create an electrode that just goes inside these two slots. So just as you saw me do on the second electrode, I'm going to select two faces which just cover the extents. Come into my solid toolbar here, take a solid core capture around there, and apply an oversize of 0.5 millimeters. Then again, just increase the height here so I've got enough clearance away from the rest of the insert. So here I'm going to raise it to 9 millimeters. That's been done. Now I just need to apply some clearance. So first of all, I'm going to select these two inside faces and do a replace face to the outside. And now I need to move these top faces up. I have quite a lot of different form here. So what I'm going to do, I'm just going to do a measurement first of all using standard PowerSHAPE functionality. Just do a two-point measure. Here I can see I've got a distance of just under 6.25 millimeters. So what I'm going to do now is just select these individual faces, holding down my shift key when I select each additional face from the first. Then when I do a replace face, I'm going to enter here a distance of -4 millimeters. That's going to be from the top. I have a blue outline. When I click apply, all those faces then have been removed to a nice flat face. Makes it much easier for machining. Turn the insert on. All that's left for me to do now is just turn this solid core capture into an electrode. So here, I just need to come into my electrode wizard. This instance has included base no. A blank size has been applied for me, which is correct. Now just apply that holder. The count has been increased for me, but now I want to show some new functionality. So here, in the combined setup sheet, under all views, we have new functionality that's available for us for automatic dimensioning. Now this is dependent on the view you've got on your setting sheet. So an isometric view gives a different result to a plan view, different functionality becomes available. So here we can automatically dimension the blank size, the base, the frame that was automatically created for us here, the burn area, the workpiece and the electrode position relative to the tool with which it was taken. This instance we're going to do the frame, enable the Y dimension and the X dimension to be labelled. Here it's a one-off modification, it's going to do just for this one electrode. And now here, under the spark gaps, it's calculated one for me, but based on my previous experience and knowledge, I can change that manually very easily, and I could save that for future reference. So next time I have an electrode of this surface finish, with this area, on this electrode material, with this workpiece material, it would then remember the result and automatically populate the form for me. Now I'm going to export this, so I'm going to select here for my EDM data transfer files. Here we have the major OEMs supported for us as standard. This is the standard that comes with the Electrode Design Wizard. I'm going to export in the Mitsubishi NC format. What I'm also going to do is create the inspection points for PowerINSPECT. Now this functionality is with the Electrode Design Wizard license. It's quite a small electrode, and we'll change the probe radius here to 1.5 millimeters. Now, using the intelligent cursor, which is a very popular feature in PowerSHAPE, I can use the wizard to then create inspection points, first of all around the frame, and then on the impression itself. So here, at the top of the face centre, I know I'm exactly on the centre. I'll do one for my overall depth. On the far side here, I can just do one on that rear face. If I create a point and I would like it moved, I can just click it and then reapply. Click accept, and that's done. And now I can browse to my location with my directory set now of where I'd like this exported to. I can select finish, and the Trode file will be created for me. The 3 electrodes will be written to the Trode file together with the drawings, the setting information, and will automatically have the script file created for us. Don't wish to create another electrode, but here I'm just going to select everything on this level, zoom in. We can see then that frame size has been automatically created for us. The general assembly sheet has been updated. And when I come back to the mold tool here, turn the electrode groupings off, come to this final electrode, and use my right mouse button, turn my burn area shading on. So here, the green is the blank size, the purple is the frame size, red burn area, and yellow is clearance. Identify all the parts of the electrode, and come into the simulation, and see now the electrode leave and re-enter the job as it is for usage on the machine. Now, if we look at the results that have been created here, we can see the Trode file has been created and the NC file. If I come into my notepad, what we'll see now is that for the first electrode we have the XYZ position, and at the end here we have the spark gap information, the undersize information. Second electrode, the XYZ, here we can see the rotations, and here is the third electrode, together with their differing spark gap, undersize information here at the end. We will now go into PowerMILL and extract an electrode ready for machining. In PowerMILL, I can extract the electrode now from the Trode file. I have the 3 electrodes shown here, all colour coded. This instance I'm going to select SPM3. We will have all the colour formats here displayed. There's a key on the left hand side which indicates the areas of the frame, the base, clearance, extension and the burn area. I can change the blank height here, the base height. Now that is information was created in PowerSHAPE. Now it's been passed through into PowerMILL. I can interrogate for minimum radius or the draft angle interactively. Now for previously defined templates saved previously, they've been reloaded into my PowerMILL session. These are created by the user, and then the undersize information, the spark gap information is automatically applied for each individual template. If I go over now and have a look at the imported templates, we see the name of the electrode, SPM3. There's the finish electrode, here's the undersize. We have all the templates imported. So if I was to look at a finishing template here, we'll see that thickness there, 0.1 millimeters negative. That undersize has been automatically applied. I can deactivate, hit finish. What will happen now that the heights of the toolpaths are being set, then they're being automatically calculated in PowerMILL. What we'll see here now for each of these toolpaths is the model area clearance toolpath. We've now got a flat finish that will just finish the base. We have an automatic toolpath here, the steep and shallow, that goes all over the impression. We have the corner finishings, which those corners are machined out. Then we have a finishing toolpath for the frame. If I go to the NC program, we have a folder now created. They've all been automatically applied. I can now do a write. That's going to create that NC program. That's all been written out. I can now look at the NC program, the NC code that's been produced. Edit with Notepad, and here now is all the G code and NC code data for that electrode. Having done that, I can now go into PowerInspect and inspect the electrode. We can now extract the electrode from the trode file using the Electrode Inspection Wizard. This is in CNC or OMV format. Here it's CNC. We can select the trode file that's created earlier and extract the electrode from that. The physical CAD geometry is now being imported. And move the probe away from the imported electrode. Select my finisher points. So we're going to do a demonstration. We're going to use the simulated measure. Then on the play item, we're going to use the user-defined alignment. Then automatically create the probe paths for the points that we created in PowerSHAPE. Once that is done, I've run the probe paths. I do wish to create a best fit. So what I can do now, just by selecting either of the points, come into my alignments, do a best fit. So here on the method, I'm going to go to 2D best fit and transfer all the points across. Apply and OK. And now just play the item for the best fit. So for each point that needs a best fit done to it, we'll just go step, then click OK. Once that is done, I'll go to next through the wizard and view the results. The first report we'll have on the screen is the inspection report. So you see the HTML file here in PowerInspect. All the customizable information at the top can be displayed. The deviations are shown for each of the points, for each part of the electrode. Now when I click next, what we'll see now is the inspection report results of the best fit. And we can apply these now to the original script file, the original output file that's going to be sent to the EDM machine. So when I click finish now, this is written into the trode file. Here is the original NC file. Now here on the trode file, when I press my right mouse button, we have the new Delcam electrode option. That's just for that trode file. So we can view the HTML, the general assembly and detailed drawing, but we can also extract the HTML, extract the geometry of the CAD file of the electrode, also inspection data, the original EDM script, but also the corrected EDM script. That's the EDM script based on the inspection results. So when I click here, the Mitsubishi NC, so this will give me the corrected NC script. I can make a new folder. In here, I'll just type new data. Then when I click OK, that new updated script will be automatically created in that folder. Look at that new folder here. Edit that with Notepad++. Here is that third electrode, 1, 2, 3, that third electrode SPM3. And when I compare that to the original, we can see here the changes to the original EDM script. So not only can we create the EDM script in PowerSHAPE, which is theoretically correct with all the exact information, when inspection has done that electrode, we can update that automatically, and then all the user has to do is just extract it from the trode file, and it has the most latest and up-to-date information to automatically import into his EDM machine, giving him the highest precision for use of that electrode